All right, today we're going to talk about sections 13.5 and 13.6 dealing with three-dimensional graphing and equations of circles. This is an example of a three-dimensional graph where we have the x-axis, the y-axis, and the z-axis that we have to look at. And when we're talking about three-dimensional figures, we could talk about taking something from two-dimensional and rotating it around the y-axis to create a three-dimensional figure. And an example of what that would look like if we were to take something similar to B, if we were to take a rectangular prism here and rotate it around this axis of revolution, which could be our y-axis, you could see that we would create a cylinder. It's taking a rectangular prism and revolving it around, and we would create a cylinder. So what do we think we would create if we took a triangle and revolved it around the y-axis? We would create a cone. And then lastly, taking this half circle and revolving it around, we would create a sphere. So that's connecting it to what we were just talking about with surface area and volume and having our three-dimensional figures, but that's taking it from the two-dimensional plane that we've had and then putting it onto 3D. What would it look like in order to graph a three-dimensional figure? So I'm going to cheat a little bit and take our previous diagram. So to graph the 3, 6, 9, we would go 3 units along the x-axis, we'd go 6 units along the y-axis, then we'd go up 9 units, 1, 7, 8, 9. We'd be talking about a point roughly around there. And for part B, it says find the diagonal of that solid. So to find the diagonal, we have to go from the top corner all the way down to the other corner, which is at the origin. Well, in order to do that, we really need to find the diagonal of the base first, and use this triangle here in order to find the diagonal of the base. And then after we find that side, we can then use the height that we have in order to find the diagonal of the entire thing. Well, in order to do that of the base, we have dimensions of 3 and 6. So we can use Pythagorean theorem to find out that 36 and 9, we get the square root of 45, which simplifies to 3 root 5. And then when doing that, so we have that dimension right there, we have the height of 9, we can then find the diagonal of the solid using our new triangle. And when we use Pythagorean theorem there, we get the square root of 126, which we could simplify to 3 square root 14. Now, I don't want to do that every single time, so we are going to have a formula for 3D distance. And it's very similar to the formula that you guys are used to with the distance formula. We just need to incorporate the third coordinate. So using that formula, why don't you plug in the next part to find the distance of between A and B. And when we get done plugging that in, we can find out the distance between A and B is the square root of 89. The next part we're going to review talking about circles and the circle formula, if we recall from review. And then what we need to remember here is that the center is h comma k within this formula, and the radius is r. So we'll need to square root that number, whatever it is, in order to find the radius. And one of the common things that we would have to do with this is completing the square. because we need to turn it into that formula. So we're going to group our x's together, and I'll explain why I have that like this in a second. And then we're going to group our y's together, and then we're going to move the 13 to the other side. So now in this case, we need to find a way in order for our formula to look like we talked about right here, and we need to find a way to complete that square. Well, in order for us to get a perfect square on that side, we're going to take half of -8, which is 4. In order for this to be x minus 4 squared, we need to add a 16 here. 4 squared is 16, but I can't add it just to the left side, so I need to add it to the right side as well in order to make it equivalent. I'm going to do the same thing for the y's. Half of 2 is 1, squared is 1, but I can't add it to the left unless I add it to the right. And then when I simplify the right side there, I get 4, which tells me, based off of my formula, that the center in this case is 4, -1. And my radius is the square root of 4, which is 2. And I draw really great circles. So that would be the circle there. Now, a difference, something similar but slightly different based off of looking at this, we have to worry about the 2 in front of the x and the y. We're still going to do the same process. We're going to group the x's together. We're going to group the y's together. And we're going to move that 3 to the other side. But in this case, we need to factor out the 2 here for the x. And then the same thing for the y. And then we're going to do a very similar process. So we're still going to take, we've got to keep the factored out 2 here. We're still going to take half of -2, which is 1. Squared. So 1 squared is 1, but in this case I didn't really add a 1, I really added 2 times 1. We need to add 2 to the other side in order to keep it equivalent. And then the same thing with the y's here. Half of -4 is -2. Squared is 4, but I didn't really add a 4 because I added an 8 to both sides. And now when I simplify, I can find that the right side equals 7. So then when I take my center, I'm going to get 1, 2, and my radius is the square root of 7. Now when you have the square root, you can just approximate for the radius. So you guys can go ahead and graph that one. For the next one, we are given this particular circle and we want to write in point slope form the equation of the tangent to the circle. Now something that we need to recall when we have circles is that the tangent touches at specifically one spot, and something else that we know is that the radius to the tangent meets at a right angle. So we need to use those things in order to help us find the equation of the tangent. Now, we do know that it already has the point 8, -8. So that helps us. Well, we also are given the center of this specific circle with 2, -3. And because we know that the radius is perpendicular to the tangent, then we can find the slope of the radius to the tangent, and then we can take its opposite reciprocal in order to find the slope of the tangent. So we're going to plug in those 2 points in order to find the slope. And so we find out that this slope is -5/6, which means the slope that we want is the opposite reciprocal of 6/5. And then we can plug that in to find the equation of the tangent. Determine the equation of the circle with center 2, -3, and the circle that passes through 3, 0. So when we are given the fact that it has a center of 2, -3, and it passes through 3, 0, it's telling us a point on the circle, which means that it's telling us that if we find the distance between those 2 points, that would be the distance of the radius. So using the fact that we have the center, we can start off writing the formula. And then we can finish it by plugging these two into the distance formula, which you can go ahead and do. And we find out that this is 1 squared plus 3 squared, which is the square root of 10, and because this is the radius squared, we're going to take our radius of square root of 10 and square it, which gives us this equal to 10. And our last thing, determining if the point is on, outside, or inside the circle. Now, in this particular case, if you were to draw the actual circle, starting at the origin with the radius of 10, we're able to clearly tell if 3, 0 is inside, outside, or on the circle. But what you can always do is plug in the point, and when you plug in the point, so if you plug in 3 and 0, if when you plug it in, it is greater than, you plug it all in, it is greater than the 100 here, whatever it's equal to, and it is outside the circle. If you plug it in and it is less than it is inside the circle. If you plug it in and it is equal to, then it is on the circle. So if you plug it in this specific case, 3 squared plus 0 squared, and 100, so we have that 9 is clearly less than 100, therefore it is inside the circle. And that concludes the video for 13.5 and 13.6.